like a topographical map, you have, here's some mountain range, right? You know, you have some surface like this, some valleys, right? And what do? The contour map is a two-dimensional projection down, right? It's a two-dimensional projection down. So you've gone from 3D to how many dimensions? 2D. So the idea is you can do space curves. You can do these space surfaces. And what do they represent? They are you're taking a four-dimensional shape and you're doing the three-dimensional projection of that shape, right? So on number 4, I think it asks you for find a formula for a function f of x, y, z whose level surface f4, f equals 4 is a sphere of radius 2 centered at the origin. A sphere of radius 2 centered at the origin, that's number 4, right? What is the equation for a sphere centered at the origin of radius 2? It's going to be x squared plus y squared plus z squared is equal to 4. So let's go back to 3D to 2D land. What it's saying is you have one level surface. If you're in 2D land, that would be one level curve, right? It's one curve. So the idea is if this represents one of them, what family of curves would this be? It would be f of x, y, z is equal to just what? X squared plus y squared plus z squared. Z squared. This right here in the red box, this represents one, what do they call it, a level curve? What do they call it? Level surface, right? Level surface. So this represents one level surface of a family. What family is that in? This one right here. So that's all they're asking you for.
Well, what's the f equals 4?
That's just saying for when this whole thing, the function is f. When this whole thing equals 4, what do you get? You get this thing right there. Do you see what I'm saying? Yeah. Yeah. Oh, there it is. There's the epiphany. Nice. You doing okay on this one now? Sort of, maybe? Okay. Let's go answer that question you're going to solve for. Well, you solve for z. So if we solve for z, what do we end up with? Z is equal to
-1/3.
Yeah, we subtract everything, right? So it's going to be minus x minus 2y plus 5 all over what? All over 3, right there. So what is that? That is f of xy is equal to that right there. That's all it's asking for here. The main thrust, everybody, the main thrust for this section is not any sort of complex manipulation. It's all about just visualizing these things in 3 space. Visualization, that's it. That's part of the reason we're doing this right here. The entire reason right here is there's a lot of deep math in origami. There's some really deep math. Like, for example, this shape. One thing I've always wanted to calculate, we started with 60 sheets of paper for this, right? So let's say you start with 60 sheets that are S by S. How tall is this shape in terms of S? That's a question I've never answered, right? There's a lot of really cool math problems you can ask, but the idea is keeping you thinking about 3-dimensional manipulation by using origami. Is there deep algebraic math with regards to origami? Absolutely. There's a ton. Really cool stuff that has to do with space telescopes and heart stints, all sorts of really fun stuff, but that's just part of it. Any other general questions about 12.5? So you have what, z, x, and y? Which variable was not present in that function? Y. So it didn't really matter. So if you drew your cylinder like this, that's fine. But then what happens to it? It turns into a cylinder. It extends forward and backward in these directions, correct? So that would be for one output value. Then what happens if you put another output value into that? You would get a different radius, exactly. So then maybe you'd have a larger one. You'd have a larger one going back. So you have this shell coming around it, and it gets real busy real quick. And then as you keep on doing more values, what happens?
It's getting bigger.
It gets bigger, or you can make it smaller, correct? You can make it as small as you want it to be. It is a challenge. So what did I tell you about drawing in 3 space? There was a couple tips I gave you. Keep it simple. You see what happens when I start laying in different layers there? You suddenly gain and lose perspective. So if you have the ability to change colors, that's great. It's also really nice because you can zoom in on these, which is really great. But be careful about drawing too many lines. What happens when you draw too many lines? It gets messy really quickly. Okay, so let's transition back to what we ended up with yesterday or last week, which was I taught you how to make these pieces right here. I'm going to try to see what happens here. Remember these pieces that you made right here? So I said try to fit them together, and then you might have seen you can fit them together like this. Now here's the thing: is this the only thing you can fit them together to make? No, and this does look kind of complicated, right? It's kind of strange. It's not actually that bad. What's nice about this is that you only have to remember 2 numbers, 3 and 5. When you're looking at this star, you'll notice that you see how there's 5 points right there? Can you see that? You notice how there's 3 points right there? the joints, these like vertices, so there's a 5 right here, you can only have a 3 or a 5. You can only have a 3 or a 5. So if you start with a 3 or a 5 and keep building, it will immediately feel wrong if you try to do anything other than a 3 or a 5, and it will close in on itself. If you go a little bigger, I've done larger, this is 60, I've figured out how to do 120. When you get a little bigger, you can end up building for long enough that you end up having to like disassemble and go forward. With this, it's relatively straightforward. So you now theoretically remember how to do these pieces. There's a proper unit name for these units. I don't know what they are, but you can make these. So the idea is, if you then fold it 3 times, you end up with kind of a kinked version like this. And I did type this up for you. It's right, I think I put it right here. Anybody see that star post I made? I think I put it right here. Oh, it's loading the Smartbee right now. So this right here are the pictures for the evolution. You start with your 15 sheets of 8.5 by 11, turn it into 4 squares. You make your 60 pieces, 30 points, which is right here in the middle. And then you end up being able to stitch it together. It's kind of like paper weaving. The idea is, if you have 2 of these pieces, they fit into these pockets rather nicely together, and you end up being able to make one of these points. So if you make one of these points, how many do you need for this star?
60.
We need 60 pieces. How many points are you going to have? There's going to be 30 points. Exactly. There's going to be 30 points. So then once you have a few of them, you have 2 points like this, you can then, I'll try to do this inverted here, you can fit 2 of them together into the pockets like this, and you'll notice right here, what could you place? A 3rd point, and then you end up with a joined unit of 3, and you have the base of your star like this. So then from there, on this edge, it looks like you can create a 5 point right there, and it alternates on the second level, 5, 3, 5, 3. You get half of it, and then you invert it to seal it up. It will take practice, and what did I say about the accuracy of each of these pieces? What happens if you are a little bit inaccurate with each piece? It compounds really viciously, and I will say you guys did an amazing job for your first time making these pieces. I've done this with other classes before in other places, and a whole bunch of kids will make pieces, and I have to sit there kind of going, I can't fit this together. So good job with the accuracy. So then what you end up with is building them. Don't try to put them in piece by piece. You have to put them in point by point. So what you end up with is you end up with a hole, and then you have to keep on stitching. It's a great relaxation technique, because what happens if you get angry at paper?
Crush it.
You crush it, and then it's very sad. So when you get good at this, and when you become efficient at making the pieces, you end up being able to make one of these in about 2 hours. And it gets very sad if you crush your pieces. So what's usually the hardest piece to put in there?
Last one.
Yeah, it becomes a little hard. What's nice about the last one, there's only one way to put it in, right? There's only one gap. So you put the last one, and then you have 1 space left. So you end up with 2 flaps and 2 joinings on either side, and then you get a closed shape. Are there many other closed shapes you can make? Yeah, there's really cool ways you can fit these together to make. So anybody figure out how to make a cube? Anybody work that out? So you can make a cube, but then you can expand it to make it a 3 by 3 by 3 cube. But what can you drill down through the middle of your cube? You can actually make a cube out of it that has holes going through the sides. And I've always wanted to go one further, like 2 holes or 4 holes through each side. It ends up being 1, 2, 3, 5 by 5. It takes hundreds and hundreds of pieces. It's fun, but this is what you end up with. So your homework over break, see if you can make one of these. First thing you got to do, how many pieces do you need?
60.
And then you turn it into 30 points. So you turn it into these points right here, and then you put them together. Does that sound fun?